detour here. And when we talk about schemas, we're talking about the design of these tables. And so you should know by looking at these boxes what the spreadsheet view of these table contents would be. If I asked you to write, to insert yourself as a student, say, into the student table, then you would know to represent it on a piece of paper or on a whiteboard here. It's going to be like some spreadsheet where the first field is ID, and then the next is name, and the next is dept name, and the last column is total credits, top cred. And so if everybody in this room filled out a row, then we might have, what would you use? You might put in your star ID here. I assume star IDs are unique for the individual, but just to keep things simple, I'm just going to use an auto number field, and so record number 1 and 2 and 3 and etc. And so maybe there's a student named Neville here, and who happens to be a CS major and has 15 credits so far. And then, I don't know, some student named Bryant. It turns out that these are just last names, I think, if we actually look at the data provided with the book. And Bryant happens to be a TAD major with 39 credits. So we can, having a view of the design of these tables allows us to picture what might be in those tables. If we know what those data types are, we can make a pretty good guess. Anything with name in it is probably going to be some sort of string. Credits is probably going to be an integer, even though I think they're represented as floating point numbers on your transcripts, I think, maybe. I don't know. And ID, well, generally, the cheapest form of memory storage data type is going to be integer, and so usually ID is going to be an integer. And I don't know, for your typical system, that integer is probably a 64-bit integer. If you have a 64-bit operating system, I think that's fairly standard these days. And so it's not necessarily tiny, and maybe we can get away with smaller storages for IDs, but having a large ID or a large integer serve as your auto number field, it guarantees at least that you're going to be able to generate millions and millions of unique IDs for all of the unique people who end up registering at this university. All right, but back to what I was talking about on Wednesday. Is today Wednesday? On Monday, I was talking about this course section schema. So again, this is a spreadsheet view, so it's an example of the data that's in the section table, so we can define the sections that are being offered of each class. We can see that during some semesters and where the value for semester is the same and the value for year is the same, we're going to see section IDs be different. So CS 190 sections 1 and 2 both take place in spring of 2009. So I talked about that already. Nobody has any questions about that, right? Don't want to beat a dead horse. But that makes sense for sections, right? That's what you would expect. If you have to represent a section as an object variable or as a concept within this database, then this is a decent way of figuring out how to represent that. Anyone remember what time slot ID stands for again? Why is there a letter in the time slot ID field? Does that matter? Letters are kind of like integers, so probably doesn't matter. as long as it's not a string of multiple characters. It'll be just as cheap as an integer. You remember what does our schema diagram tell us about that? Let me back up to my schema diagram. So we were in the section table, which is far left side of the screen, and course ID, section ID, semester, year, building, room number, and time slot ID. That was the letter field, right? A, B, C, D, E, whatever. And that's a value from apparently time slots are also entities. What is a time slot entity? Do you remember, Tyler? Can you describe it for me?
Well, I can look at it.
Yeah.
It has an ID, a day, and the start and end time that defines when it starts and ends and what days the classes are. At least the
Yeah.
time slot.
So if I told you to generate an example time slot table for me, you would generate something with probably 4 columns, right? And what would be the values in, like, for the first record, say?
Let's see.
For TS ID, and then day, and start, and end. Give me 4 values that will define a time slot during which a class could be taught.
All right. Well, time slot A will be.
Okay.
That'll be days Monday, Wednesday, Friday.
Yeah.
They'll start at, let's see, what time is this? 2 to
Yeah.
2:50. That'll represent this time slot.
Yeah. And then another time slot might be ID D, and it's Monday, Wednesday, Friday from 9 to 9:50 a.m. And time slot F might be Tuesday, Thursdays from noon to 1:50. And time slot Z might be Fridays. People love Friday classes at what, 3 p.m.? 3 to 5 p.m. on Fridays. That's when we go to college algebra class. So, yeah. And so I guess what that line is showing, and again, hey, I've got a pen in my hand, I might as well make my correction on something that I'm not actually going to draw on. Oh, just off the screen. I meant to draw this little arrow right here, because everybody else has got an arrowhead and not this guy. But, okay, so he is actually pointing not at day, but at time slot ID up there. And what that's saying is we've got these individual values here, and this field is getting its value from this field. And so if I were to put an A in this column of this row, this record here, in the section table, then maybe this is one of the sections during which Calculus 1 is being taught. Then that calculus class is only being taught 3 hours a week, apparently, on Monday, Wednesday, Fridays, at the same time as this class.
It's like it's differential equations.
Or maybe it's differential equations. But again, I think the main point that I wanted to communicate on Monday is that the fact that we're using this value in this column means this value, this A, this cheap little storage value, is representing everything else in here with just one letter. And if I've got a CS 3507, some sort of database class or something that's also being taught in slot A, then there's going to be an A in another record. But so far we've spent memory storage for 2 A's, relatively cheap, and both of those A's map to the same row in the time slot table. And so that's how we save save memory, this is some sort of string, which is way more expensive than a single integer. This is at least 3 times as big as an integer, probably. And I don't know how those are stored. Maybe those are strings as well. And so representing a whole bunch of strings with just a single cheap little unique ID is a fantastically efficient way of storage. This stuff is only printed once. That space is only wasted once. And that time slot can be represented for classes in all kinds of departments on this campus. All right. So I think that's about where I was stopped with this section business when I ran out of time last time. So now look at your schema diagram. And can you use that? We know that, I've just shown you how the course section ID is associated with the time slot ID table. Basically, it's through those lines that connect them together on same value fields. So now my question is, how could you associate instructors and the courses they teach in this schema diagram? Because the way that we uniquely represent, the way that we represented a unique time slot in the section table is we just put its ID there, its representative, in the time slot ID field. And that A or B or C, that maps to a single row whose time slot ID is A, B, or C. And that's how we're sort of tying this row to all the details for time slot B in that table. This is another class that gets taught from 2 to 2:50 on Monday, Wednesday, Fridays, according to my definition in my database. And so what's my question? How to associate instructors and the courses they teach? Because, you know, when you're displaying the schedule for the current semester, and you know that there's some computer science instructors that you really, really want to avoid, you'd like to have the instructors' names right there by the names of their courses, so you have a reminder not to take those courses. And so we have Neville in this instructor table here, apparently. And we have a bunch of courses, some of which are taught by Neville. What was the question again? Information on 2 separate slides. How to associate instructors and the courses they teach, right? So I'm talking about the course table, and I'm talking about the instructor table, right? Let me go back and check that question. Instructors and courses they teach. Those are the objects we're talking about. And so you might assume correctly that what we need to do is find a path of lines that connects the items in the instructor table to the items in the course table. But they probably want to be lines that make sense for whatever you're trying to do. You're trying to associate instructors and the courses that they teach somehow. And so I can see that there's a line that goes from instructor to department to course, but I'm not, if I were to combine all of those values together into a single table, I've got course ID and department name is going to be the same between those two and those two. I mean, for computer science this semester, it's hard, but if we still had 3 computer science instructors, then department name wouldn't be a really good piece of glue to glue Neville to all of Neville's classes, because also Bao Zhang's classes are department name CS, and also Professor Wolf's classes are department name CS. So not every path is equally good is what I'm trying to say. And you might have noticed by now, you're probably wondering why I'm not talking about it. Nobody's wondering that. You just know that I'm wasting your time. But there's actually a relationship that makes sense in here that has something to do with instructors teaching classes, that both courses and instructor are connected to, right? And I mean, the homework one that I gave you, where most of you created 3 tables and tied them together, we don't see that kind of relationship between course and instructor, do we? I mean, we see it through department, I suppose, but again, department, if we match computer science could match to different people, and so that's why that's not going to be good. But what's good about this line here is if we combine these 2 tables based on the 2 things that are being connected by this line generally means equality, and so only values whose IDs are the same between those 2 tables will have their rows concatenated together. So whatever Neville's ID is in the instructor table will only connect to the entities in here, which are apparently the course IDs that are taught by Neville, and then all of the associated values of course IDs. But also, if we're going this way, I mean, actually, and we don't have to be limited by the lines that we see. If we can find a value that's a field that's going to be the same between those 2 tables, we can draw a new line dynamically here. And it turns out I could probably just, if I were in the design view, drag and drop, I could just drag and drop this course ID field to that course ID field. They're probably the same data type, right? With the same values that mean the same thing. I mean, you can't always count on that with the fields that have exactly the same name, but here probably yes, right? This example is probably not trying to trick us. So, you might look at this and say, well, it makes sense to go this way, but if I go this way, then I have to go through here and then go through here. But really, if we are crafting our own query, and we don't really care to distinguish between sections, we don't need that information in here. And anyway, we've got a section ID here if we did need it. But if all we care about is connecting instructors to the classes that they teach, we can just have a line that goes from here to here, and from course ID to course ID. Again, assuming that this ID uniquely is a unique ID that uniquely represents each course there. And this is about the time when I should tell you what underlines mean in these tables. Underlines mean unique IDs. You remember how I said Access likes to automatically define something as a primary key in your tables. Only unique values can be primary key fields, and that just helps Access work faster if it can as it's connecting tables together. And that's the sort of thing that we look for. That's the sort of thing that the primary key looks for. That's the type of column that's valid as a choice or useful as a choice for primary key. I mean, you can make any field a primary key if you want, but it might screw things up because it won't allow you to put duplicate values in. And so depending on the field that you're talking about, that may be a field you want to allow duplicate values in. So I think that makes sense for course ID, that we know that those are all going to be unique fields. But what I should also say is that just the fact that a field is underlined doesn't mean that its values are unique. Because you would imagine in the teaches table, Neville teaches what, 3 or 4 classes each semester? So I would imagine that Neville would have, for this semester, fall of 25, and maybe all of my section IDs are 1. and then I would have my 4 unique courses that I teach this semester, but I would probably have 4 rows in this table here for fall of 25, which means ID is not a unique value in this field. What is unique is the combination of all of these values. Because maybe I'm teaching 2 sections of 3507 this semester, so course ID is also not going to be unique here, but it will be ID and course ID and section IDs 1 and 2, so that would be 2 records that I have for this semester. And they're also underlining semester and year, because what if I taught databases last semester too, or last year? That record is also in here. And so just course ID and section ID combined with professor ID can't be unique. And so we have to bring semester in. And if I taught in both semesters of 2025, which haven't occurred yet, but also if I'm teaching this class every year, and every year I have 1 or 2, every semester I have 1 or 2 database courses added to that table. The only way to make a record unique is to combine the values of all the fields together into one massive combo record. And that's what the underlines mean, is these aren't individually unique, it's when they're taken together that they're unique. Classrooms in a building, there's more than just one classroom in a building. Your classroom isn't going to be unique just with a building name. But building name and room number, that unifies a classroom. There's only going to be one location in Hag Sauer, number 205. Are we Hag Sauer? All right, so anyway, we have a bunch of obvious connections between these tables, but you know, if we see a way of connecting something that's a unique representative in this table to something that will truly be unique in another table, we can always draw additional lines as needed if we don't need any of the information, all the information along the path that we do see drawn in that diagram. But yeah, if I gave you a Microsoft Access database that had all of these tables in it, and I asked you to make me a query that connected all of the instructors together with their courses, and you didn't know any better, you could probably just, drag out the instructor table, the teachers table, the section table, the course ID table, and the most obvious thing to do would be to drag and drop ID to ID, and then these 4 to these 4, and then course ID to course ID, and then you click the red exclamation point, and it brings back a concatenation of all of these columns. So all of your rows that would come back would be, whatever, 12 columns or 15 columns wide there. And they would have matching values between the tables on which the connections were made. And do you guys remember what that command was in SQL? Yeah. Inner join, I think it was called. I just looked that up before coming over here today, so let me drop out of the slideshow here and go to Microsoft Access. Go back to my example, that actors query. What is it? Design view of the query? Sure, yeah, okay. And again, I didn't have a very good name for that glue table. If I were doing it today, I would probably call that acts in. Man, nobody back here can see anything that's written up here. But, what was I talking about? Oh yeah. We have 8 columns of data between these 2 tables. You guys know why you only saw 2 columns of data when you saw the spreadsheet view just before I changed to design view? It's because of those check marks. Right? I'm going to go back to design view. There's only two column names, actor name and movie name. Back to design view, because I have actors.actor name here and movies.movie name here. If I, how do I delete things? Cut maybe? There's a cut, and there's a cut. If I wanted to show you all of the data that actually got put together in order for you to see that simple representation that only contained the data that you cared about, the movie names and the actor names who were starring in those movies. And so this is actually going to generate a 7-column table, but it's doing it in a short way. I'm just using wildcard characters, those stars. When I hit run on this, I'm saying everything in movies, everything in other, everything in the actors table, where those values match. And so we should have the same number of rows in this view as we did in the original view. It's just before I was just saying, show me movie name and actor name and filter everything out. But I guess what I want you to see with this here, do I have a magnifying glass? It doesn't look like it. I can't make this any bigger. Oh, so these are the 3 movie table columns, and then this is the movie ID column in the glue field, and you'll notice that movie ID in the movie table is always the same as movie ID in the glue table, because that is how those rows are being glued together. Avengers Age of Ultron is not going to be glued together with movie ID 2 in that glue table. It's only going to be concatenated with the row that has the same value that field was drag and dropped from. And this is the other table. That movie ID is connected, it's only 2 columns. It's connected with actor ID field, and that field value is the same as the field value in the actor table, another 2-column table. And again, all of these values as we go down are the same between these 2 fields. That's what those lines do on that schema diagram in front of you. They only concatenate those rows where those connected values are the same. And those connected values, for this to work, need to be unique. If I were looking at an individual table here, say the actors table, design view, okay, sure. No. Apparently, I'm in some sort of view in the query that doesn't like the source table to be open. No. Oh yeah, because I changed the design. Maybe. Fine. So go back to design view. You might recognize this design as a design on your schema diagram where we have we have an actor ID that represents actor name and maybe other things about those actors, but we're trying to represent expensive data, string data, with a number field here. And so actor ID, we assume in that actor table, every individual unique actor is going to be represented by a unique number. We're not going to have Nicolas Cage in this table twice. There's no reason. This is the actors table. Once Nicolas Cage is in it once, then unless there's another actor named Nicolas Cage, there's only going to be one Nicolas Cage record in this table. And whatever number is in the actor ID field in front of Nicolas Cage, anytime Nicolas Cage is in a movie, we can just put that number in another table, and that represents Nicolas Cage and all of his other columns of information in this table here. So while I'm here, I could just select this field and make it primary key. And when I do that, Access looks at all of the values in the actor ID field, and if none of those values are repeated, as long as all of those values are unique, then it's going to let that be a primary field. And the fact that my data type is auto number means that there was no chance of anything being duplicated in those columns. But just to be sure, I'm going to go back to the actor table, and yeah, 1, 2, 3, 5. There are no repeated numbers there. But if I look at my other table, I don't think my actor ID can be unique in this table. And I don't think my movie ID can be unique in this table. Right? Because I have duplicated values, and primary key is going to give me an error, I think. In fact, I might as well try that out if it has any duplicate values. Let me try that out. Because I don't have any unique ID uniquely representing my acts in relationship, which I believe is what this combination of values means. I would have to add a new column, some sort of ID field, if I cared to uniquely represent these relationships. Let me go back to design view and try to make that a primary key. You're going to let me do that? What if I save? Okay, thank you. The changes I requested were not successful because they would create duplicate values in the index, primary key, or relationship. So primary key is relevant there. So that's failing because it's not going to let me save that until I turn off primary key, because primary key demands uniqueness in its values in order to, basically, it's probably going to order those values by that field. On the hard drive somewhere, to make them easy to retrieve quickly. How do you quickly retrieve a numeric value that some other table has said, okay, well look for timestamp ID A, not timestamp. What am I talking about? Time slot ID A, or value 92, or whatever the ID value is. If you know that the ID values are sorted in numeric order somewhere on the database, how do you find the value 92 super quickly? Yeah, the numbers are scattered from here to here, from location 1 to 1,000. All of the IDs. I want you to find 92 super quickly.
Right here, like it's 1 to 1,000. It's not like right here.
They're in locations 1 to 1,000, but maybe the numbers are from 1 to 1,000,000.
Okay.
The IDs are 1 to 1,000,000, say. But they're unique. So I don't exactly know where 92 is going to be. I mean, probably I could guess it's towards the front. But you guys all know a super quick algorithm for finding a number in a sorted array, right?
Oh, no.
Look in slot 500. If that's greater than 92, look in slot 250. If that's greater than 92, look in slot 125. Right?
Binary sort.
It's the fastest way to find anything, as long as values are sorted. That's probably how primary key works. That's probably, primary key is supposed to make data retrieval faster. It's probably a putting those numbers in a location where they can be binary searched through to quickly find a record given its ID number in logarithmic time.
So like if it wasn't sorted, you'd be doing like just like
Sequential.
like sequential
Yeah.
sort. But because it's sorted, they can do binary sort.
Yes.
Okay.
Yep. All right. So I was reviewing information to contextualize the next boring slide that I was going to show you. Is this dry for you people? Not as exciting as cat and dog objects, not as colorful. I mean, freaking section entities. Who cares about section entities and time slot entities? I guess the person who's being paid $80,000 to program that database system. So we've associated instructors and courses they teach by a sequence of unique values that connect us from table to table. What uniquely identifies an instructor? Look on your diagram sheet. What does uniquely identify an instructor? You only need one thing, right? you need instructor.id. That will, every instructor has a unique star ID. If you have a star ID, you can search through that table. Once you find that value, you have that one instructor that is mapped to that ID. What uniquely identifies a section? What does the diagram say? Oh, I'm taking you the long way through teaches and section back to course. What makes a section unique? Well, the course that's being taught. Remember, I'm teaching 2 sections of CS 3507 in fall of 25. So CS 3507, section 1, semester fall, year 25. And then, all of those underlined things are required for a unique section. Because my other section, my second offering of databases this semester, is going to be CS 3507, section 2, fall and 25. So it's the combination of those 4 attributes that make for a unique section ID. And that's why those things, those fields are underlined. If you want to reference a section in another table, you have to copy those 4 values from the section table to uniquely identify a single row of a course that is being taught in a particular section, in a particular semester and year. I think I've talked enough about teaches. I mean, I don't necessarily know just by looking at this table what makes a teaches entity, a teaches relationship unique. But you can look at your schema diagram. What makes a teaches record unique? Is it just the teaches ID? I don't think so, because the ID in teaches, that's the instructor teaching the class. And so again, for every class being taught in fall 2009, that instructor is going to have their ID there. So ID is definitely not a unique field. So if I combine instructor and course ID together, does that make it unique? Well, as long as that course doesn't have 2 sections taught by the same instructor. So already, we've got these 3 fields appear to need to be combined together. It's not enough just to combine 2 fields together to get something unique, because that's not going to distinguish these 2 records. But and you know, spring 2009, I guess sections will always be in the same semester and year. That's what makes them separate sections. But yeah, maybe just ID, course ID, and section ID is enough to uniquify a thing, since the other 2 values will always be the same. What does the schema diagram say about, what am I looking at? Teaches? It's putting everything together, semester and year. But I don't think it needs.
Which one do you think it doesn't need?
No, I guess, yeah. Because I could be teaching 2 sections of that in the fall also, and in 2008 also in both spring and fall. And so yeah, now, I even said that before and forgot it. But yeah, I guess in order to uniquely identify any row in this table, I need every value in this table. And if another table needs to reference a teaches relationship, which I don't think any of them do. No, maybe they do, because I see a whole bunch of lines. Oh, no, it's the teaches that's referencing the 4 attributes that make a section unique, and it's also referencing the field in the instructor table that makes the instructor unique. And it's putting those 2 unique values together to create a unique teaches relationship. But there is no other table that takes all 5 of those values to represent teacher's relationship. That's not something worth representing, really, in another table. Because we wouldn't be saving any space by doing that, I guess. Although if we did need to, for whatever reason, represent a teacher's relationship in another table, we would probably add a teacher's ID column to this just to represent each row by a single number rather than having strings and numbers represent that thing. Yeah?
Doesn't our school combine like semester and year, so like fall 2009 aren't too big, it's like FA09 or something like that?
Well, that's how they print it, but courses are only taught during one semester, so they're actually, in fact, separated.
Okay.
Yeah. They're two data types, but in order to print stuff out prettily, they're gonna say F25 or something, because that's all you care about. You just care about this semester, or last semester, or next semester. And so they're just representing, using those quick strings to represent those things. Okay. So I thought I had found something that I could use later, and then you reminded me that, no, that's, maybe I'll have an example. I bet I'm remembering that I will have an example now. All right, so. Oh, yeah. So let me just skip past these other tables in the university database. I've been talking about primary keys. Anybody want to hear the mathematical definition for key? So, we've already said that Access, in order to define a primary key, wants a unique way to specify a row in a table to be able to distinguish them. And of course, the author here is using the mathematical terms tuples and relation, but we know that tuples means row and relation means table. And so if we're going to have some sort of unique ID that we can build a key on, that can uniquely distinguish any two rows within a table, then we can't allow the ID that we're keying on to have non-unique values. That's what those two lines are saying, right? And hopefully that makes obvious sense. Almost, I probably shouldn't even have needed to say so. But let me introduce some vocabulary. If you can find a set of attributes in one of your tables which in combination will uniquely identify any given row, like say all of the values in the teachers table taken together will uniquely identify any given teachers relationship in a semester and year, or any course ID value in the course table will uniquely identify every particular course that is taught at this university. Any set of attributes that provide uniqueness are called superkey values. And any given table can contain several such combinations of values that all qualify as superkeys, because all they need to do is, in combination, uniquely identify any given row. So we already know, due to the fact that the ID field in the instructor table is underlined, that all of the ID values are unique. I can represent any instructor in the table just by their unique ID. All the other data will come with it. But technically, since the IDs are unique, another superkey for the instructor table is the combination of ID and name. Right? Because even if there are multiple Professor Nevilles at BSU, only one of them will have my ID. That should be my record. Right? And any other Professor Neville, Mrs. Neville, if she's teaching at the university, will have a different ID. And you're probably wondering to yourselves, but if this already provided uniqueness, why would you bother to do this? And what you wouldn't. because you want to do the least work possible. You would stop with one column if all you needed to use was one column. But they're technically saying that technically this also fits this definition. This combination of values also uniquely identifies the tuple because, I mean, ID has already done the heavy lifting of uniquely identifying. So a unique ID combined with anything else is still going to be unique.
It could be for like clarity, like if every like professor was an ID, it'd be like, oh, I have Professor 1357. It's like, well, that's not very legible, so maybe having a name attached to it would be like, oh, I have Professor Neville, you know, like,
Yeah.
make it a bit more readable for like humans.
Yeah. No, we don't give a shit about humans and simplifying their lives. No, this is for computers.
Okay.
And all a computer needs to know is the numbers or the bits. All the computer cares about is the bits. I'm not even bringing you down to the bit level, but but the computer wants this to be a unique sequence of bits. But we just see this as a unique sequence of digits, and we feel like we understand that, and that makes us happy. Although you're right, my ID, whatever it is, whatever 1, 2, 3, 4, 5, 6, 9 or something. Wouldn't mean anything to you if that's what you saw in the class roster, the semester schedule or whatever. But no, we're just saying for the computer, in order to take the first step towards defining something in Access as a primary key, first the combination of fields, because I only selected one field, I guess I could have shift-clicked and selected multiple fields, and then they would all have lit up with golden keys. If in combination, they were unique. And so I didn't think to do that. But that's what's going on here. That's what the programmers had to program when they were programming Microsoft Access, is should we allow this person to make this field or this combination of fields a primary key? Does it meet the definition of super key? So basically, what I'm saying with this here is basically once you have something that uniquely identifies a record in a table, then any superset, any combination of that unique field with any other combination of values is also going to be a super key. Once you've found a minimal unifier, then anything including that unifier, but having extra information, the unifier already made things unique, and so the extra information isn't making anything any more unique. So any superset of a super key is a super key. But we care about minimal super keys, right? If we're going to want to identify unique values, we want to use as few columns as possible. And so if we had a choice between these two, we would probably choose this, even though this technically also applies. I'm not going to click and shift click on two fields if I know that the first field is already unique. But I guess Access would allow me to create a larger super key, or select a superset super key as a primary key in my table. So anyway, out of all the possibilities that make our row, can uniquely identify our rows, this is the only candidate key. So the thing that we care about is the candidate key. That's probably the vocabulary that we care about. And so a primary key is a candidate key chosen by the person trying to define the primary key, the database designer or programmer or whatever, as telling Access this is what you should use to order the data to uniquely identify the rows in this table. So that golden key button in Microsoft Access is relying on you choosing a minimal superset that uniquely identifies your rows, and there may actually be multiple. You might have a couple of options within a table depending on how it's designed, not in any of these tables, but anything that matches that minimal unifier definition can be chosen is generally what is chosen as a primary key. And a key is a table-wide property. So the way that you order your rows in your table is applies to the entire table. No two rows are allowed to have the same values in their primary key attributes because they have to be unique, right? I think this is just repeating stuff that we already know. Okay, so I think I'm out of time, so I'll stop there. I didn't get to the math yet, though. Oh, there were sets and supersets and subsets coming up.
It was ruined.
Next time.